Good.
All right, very good. All right, well, thanks everyone for joining. We had 28 people. I last looked just then, so that was a pretty good group of people. So this is pretty good. So I'm Kevin Hook, KK6 DCT. This is the first time we've tried to do this, so it looks like it's working okay so far. But I think we should have a couple of rules just in case. We'll keep everyone muted while Phil's doing his presentation, just so we don't have any background noise going on. And then I think what we'll do is, rather than take questions as Phil is presenting, you can either wait until the end and then we'll open the mics and people can do Q&A then. Or if you look along the bottom bar of the Zoom thing, there's a chat window. And if you click on it, you can type in a question, and then we can get Phil to pick up the questions after he's finished his presentation at the end. So I think that's what we'll try and do and see how it goes. Yeah, do we want to try and do a quick roundtable intro like we normally do at the meetings? This might be a bit chaotic because I'm not quite sure how we're going to introduce each turn.
Since you've got them listed there, I don't know that it's necessary. You'll have a...
Okay, all right. Everyone can just wave and then we'll all say hi. That works.
There's Tom.
Good. Okay.
Question, are we recording this?
Oh, sorry?
Are we recording this?
Typing in the chat window.
Yes, we are. So it is recording as well. So at the end, we'll have a recording and Carol will get it uploaded to the website for us as well. So anyone who couldn't make it live tonight, they should be able to see the replay. Phil, did you want to do a quick update on our club membership and treasury?
I will. Currently, we have 145 members. I just added 2 new ones today. Of our membership, 83.6% are members of ARRL, but currently we still have 40 unpaid members for 2020. And it would be helpful if those who are in arrears to log in and PayPal it or mail it or something. Currently, our treasury has $7,737.20. We had a $300 check that we sent out to pay insurance, our liability insurance annual fee. And we also had $579, or $479, I should say, that went to Barbara McIntyre, Paul's widow. It was the collection that we took up at the last club meeting. So we're in good shape financially. We've got a strong membership, and we still have a few that are in the rears, and it'd be nice, helpful if they were to catch that up. That covers those portions, Kevin.
All right, thank you. And then Carol, you wanted to give us an update on our club website?
Sure, if I can go ahead and share my screen.
Yep.
Okay, see how this works. Okay, you seeing my screen?
Yep, it's good, yep.
Okay, let's see how this works. I've not done this before. Okay, just to remind everyone that our website is n6na.org. We have a lot of resources on there, like a calendar down here to tell us what activities are going on for the club. And just to make sure that you check if you have any questions about the club, go to our website first. For the March 2020, we did have a total of the increase in page views went up from 1388 in February up to 2047 in March. So it was, wow, a pretty significant amount increase in website activity. And if you look here at the by day, the activity actually peaked a lot right around March 1st and March 2nd. And those were the first few days after it was publicized that Paul McIntyre had passed away. A lot of people were coming to our website to look for information about his passing and also about the memorial service, which unfortunately has had to be postponed because of the coronavirus. The most active web pages, of course, was the homepage. We had 835 page views during March. Then the magnetic loop page was 260. The 10-meter page, 106. Repeater page, 96. And so on. It goes down the list here. As far as where we got our views from, 36.5% were referred to us by Google. 37.8% were direct hits to our n6na.org URL, and the remainder referred from other sources like Facebook and Pinterest, of all things. I'm curious why we get referrals from there. And our website is seen all around the world. You can see all of the different countries that went onto our website to look for information. Most of them, of course, came from California. We had 1,508 page views from California, 37 from Texas, 23 from Spain, and there were more from these other countries and states. I just wanted to back up here. Just to remind everyone, we have an online swap page. If you have any equipment that you want to sell, or if you're looking for something that any of our club members have for sale, make sure you go and check out our swap page, because we regularly put items up there for this is a service for our members. And again, if you want to contact us, just send an email to contact@n6na.org for any material that you'd like to get up on our webpage, or if you have any questions about it. And that's it from this side. Thank you.
Okay, thanks, Carol. Do any other board members have any of the updates they want to share? Maybe not. Okay. Or is there any other general news items anyone wants to bring up this week?
Only that there's a lot of worry about Zoom.
Well, yeah. Maybe for our next meeting we'll change and we'll use something else. So we'll see how.
We're kind of committed by the time it hit.
Yeah.
Well, I do have a comment about that. I've been told that there is actually a Zoom Technologies company that's in China, but there's a separate Zoom video conferencing that's centered in Silicon Valley. So I haven't actually looked into that, but apparently they're two completely different companies. If anybody wants to verify that, if so, this might not, there may not be a big problem with our information going through China.
This is Katie, 6Qs@H.
Go ahead.
Can you hear me?
Yeah, go ahead.
I just wanted to mention I did verify the other day that we're using the Zoom from San Jose, not the other Zoom. So I think we're good. And a lot of agencies, governmental and non-governmental, and clubs are currently using it right now. Good evening, everyone.
Yeah, so just some background. Their developers are all in China, so that's the issue. Is the encryption is actually not into encryption.
Okay. I mean, for us, when we're doing kind of a public meeting anyway, we're going to record this and put it on our club website, so it'll be like publicly viewable to anyone anyway. So, you know, maybe for us it's not too much of a big deal, but I guess for some other, you know, for corporate use, it probably is a big deal. But I don't know, maybe for the next meeting we'll change and we'll use something else. But yeah, we'll see how it goes.
Try them all out and find out which one's best.
maybe each month we'll try a new one.
A quick question, anybody has any news about the health of the repeater?
Oh, I can fill you in on that a bit. I actually played golf with my mind's gone blank.
Chris?
Chris. Played golf with Chris last week, and he was telling me he had to head up.
I could just join in.
Oh, there you are.
There you go. You can give us
There's the answer. Tell him.
Oh, the repeater's ailing. The receiver up on the hill has issues, and I'm going to actually be up there tomorrow afternoon. So if you hear tones and noises and burps, just listen, because I won't engage you if you're curious about what I'm doing. But there's an interference issue with the main receiver, so we're now running with the voting system at the moment, and sometimes weak signals you can hear a heterodyne underneath. So still a work in progress. That's all I have. And that other guy I play golf with, thanks.
It was fun.
Thanks for the information.
All right. Does anyone else have anything else? Otherwise, we'll hand over to Phil for tonight's presentation.
Yeah, I think Bob Woodward wanted to say something about the health and welfare net.
Okay, Bob, go ahead.
Okay, great. Just reminding everybody that every evening at 7:30 on our River City ARCS repeater, we have a health and welfare net. There's a few hams that wanted to be included and checked on every day. And anyone else is willing and encouraged to sign up and show up and just shoot the breeze for a little while at 7:30. And so we encourage you to do that. That's about it.
Cool. Thanks, Bob.
Let me see if I can get the slideshow up here.
All right. Hey, Phil, so I'm going to mute everyone else, and then I'm going to unmute you, so you should be okay to keep talking by yourself.
Are you seeing my PowerPoint coming up on the screen?
Not yet.
I'll have to click on share screen.
Yeah. There we go. Now we're good.
Okay, now all I gotta do is find it. Okay, I'm gonna get rid of that. I'm gonna go over here. Be nice to me. Okay, before we get started here, I want to explain one thing about this. It's occurred to me that this process that I'm going to show you is applicable to any half-wave radiating element. You can end feed any of them, and that presents some really interesting opportunities. For example, if you haven't got room for a full-fledged 80-meter half-wave dipole, you could send a wire from your house to a tree, to another tree, to another tree, and as long as that total length is a half wave, this end feed arrangement I'm going to show you will work like a charm, and I think you'll be pretty happy with the results. And one of the advantages of this end feed is you don't need a ground system. Let's go on here to this next one. And that's one of the major problems oftentimes with one of these end feed arrangements. You know, you think about it, a vertical is actually an end feed. It's only a quarter wave resonator, but you're using the ground as the other quarter wave to get you to the half wave. So this whole project began, I was talking with Mike, N6MQL. He mentioned that he had this big 100-foot tree in his backyard, and he was trying to think of a way he could use that to give himself a better signal on 80 meters. And so the criteria were he wanted to resonate this down at 3.54. He's like most of us, he's got issues with homeowners association, so the magic word inconspicuous comes up. Please recognize that just because you're prohibited from having an antenna, if they don't notice it, as far as they're concerned, you don't have an antenna. And so inconspicuous is the real issue here. There's a lot of ways to feed an end-fed antenna. Sometimes you use large loading coils and high voltage capacitors or lossy transformers. And my thinking was, could I come up with a coaxial matching section to make it work? And if I do, can I do it in a straight line or a coiled configuration? So let's review what a sloper antenna is. Typically, a sloper antenna requires a counterpoise. Oftentimes, they're supported by a tower. So it's actually a quarter wave radiating element. And the other half of that, or other portion of that antenna, the other quarter wave, is typically the tower. And then there's also a full half wave element that you feed in the middle, just like a dipole. Well, here's some examples. This is a classic quarter wave sloper. I'm sure we've all seen these. There's a piece of feed line that goes up your tower, attaches to the radiating element. The tower itself bonds the shield portion of the coax, and you have a quasi-directional antenna resonant on the frequency of interest. Here's another arrangement. This is where you've got half-wave radiating elements. In this case, there's 5 of them, so you can steer your signal. But again, inconspicuous and without benefit of a tower, it doesn't apply to this presentation. So thinking about this thing, since I don't have a 100-foot tree, and I've got a fairly small yard and a homeowners association, I decided I'd do a sample project using my chimney as one supporting element, my fence at the other. And due to the space limitations, I conducted the experiment on 20 meters. And where this idea for the coax came from is, you know, this is a classic J-pole antenna. We built some in one of our meetings, I believe it was last year. Again, there's a half-wave radiating element, and recognize that a half-wave radiating element is the shortest antenna that will resonate, and it needs to be a half-wave electrically. And sometimes that means you have a piece of wire with a loading coil. Sometimes it's a piece of wire that's done in a linear loading manner, but it needs to be a half-wave to be resonant. And then the other trick with the J-pole is they use a quarter wave matching section. The reason for that is at either end of a half wave radiating element, it's the high impedance point, which also is the high voltage point. The middle of a half wave radiating element, which is where you typically would feed a dipole, is the low impedance point and the high current point. So in order to feed it on the end, you somehow have got to take the low impedance of your feed line, get it up to a high impedance to match the impedance of the half wave element at its end, and then somehow manage to transform that impedance to match your coax. And that's what's shown there on the screen. You may notice that we've got this configuration down here where they're tapping this matching section with a piece of coax. So it's 50 ohms here. It's a dead short down here. At this point, it's the high impedance of your antenna. So here's a sketch I first put together. This is the half wave radiating element. And since I was doing this on 20 meters, I used the old equation 468 divided by the frequency in megahertz, told me that this element needed to be 33 feet long, and I think everybody recognizes that as a pretty common length for a 20-meter antenna. And then we've got this matching section. Since this is a half wave, a quarter wave is going to be about half of what this one is, but it's actually shorter than that because coaxial cables, all transmission lines actually have what's called the velocity factor. The signal actually goes slower through a piece of coax than it does out the radiating element. The term velocity factor, as I said, applies there. So here's the equation I used. And by the way, this equation is wrong. The length of a quarter wave matching section is 1005. That's, if you look in the antenna books, that's the formula that you use to figure a full wave loop antenna. 1005 divided by the frequency in megahertz, then times 0.25, which is the quarter wavelength, times what the velocity factor is. And in this case, the coax I had, I measured it, and it measured a if I can get this cursor there, a 0.80 velocity factor, which told me that this line length should be 14¼ feet. But as I said, I screwed this up. So let's fix it. Here I've taken the horizontal picture and I made it a vertical picture because that's kind of how we did this. It should actually be 983.6 divided by the frequency in megahertz times 0.25 for a quarter wavelength times the velocity factor, 13.95. Unfortunately, I built the example before I found my mistake, so you're going to see that the resonance point's off a little, but it still works. The other thing that you might notice here is 8.25%. Now recognize that this is a high impedance point, this is a dead short, and based upon some other experiments I've done, I found that for 50 ohms, it works out at about 8 to 9% of the whole line length, this quarter wave line length, is the 50 ohm matching point. That'll vary based upon the characteristics of this antenna, but it will be somewhere around that, somewhere around 8, 9, 10%, okay? Let's talk about quarter wave sections of transmission line. Anyone who has an antenna analyzer might wish to try this because it's very interesting. If you take your antenna analyzer and you measure an open piece of transmission line, in this case I'm showing a piece of coax, you'll find that your antenna analyzer, when it's a quarter wavelength long, it'll look like a dead short. This end is completely open, but on this end, when you measure it, it looks like a total complete short, or very close to it. If, however, you take that same piece of transmission line, come on, cursor, wherever you went, take the same piece of transmission line, you short one end and measure it, your antenna analyzer will tell you it's open. Baffling, isn't it? But that's the characteristic of transmission lines. And this is the one we're using. If you short one end, this becomes dead short, as you said. This is the high impedance point, and you can move this tap back and forth and come up with any matching impedance between dead short and completely open. So it could be 50 ohms, it could be 75 ohms, it could be 100 ohms. If you could find some 10 ohm coax, it can be 10 ohms. So this is a veritable variable matching point. You can match any coax with it simply by moving this tap point up and down. Pretty cool. So here is where I measured a piece of coax. And I'm going to tell you what I used for coax for this example is I had a roll of RG6 TV coaxial feed line, which is about the cheapest stuff you can get. But it is a transmission line, and believe it or not, it's got some great characteristics. First of all, it's cheap. Secondly, it's got excellent attenuation characteristics. It's a very efficient transmission line. That's why every cable TV outfit in the world uses 75 ohm RG6. It's very low loss cable. Not only that, the inner conductor is made out of copper weld steel. So it's 18 gauge steel wire that has a copper plating on that center conductor. So it's got good conductivity due to the skin effect, but it's incredibly strong. It's lightweight, it's strong, it's cheap, it's low loss. That's a lot of pluses. The downside to it is, I don't think I'd be using it on any power level over about 100 watts. And you can't solder to the shield. It's all aluminum sheath and wrapped foil. So you need some special terminations, which by the way are available at any Home Depot. They cost you about $1 a piece. And they're weatherproof connectors. So it works pretty well. So I made this measurement, and you'll see up here that this feed line, see this low impedance point? That's what you're going to see on your antenna analyzer. This low impedance point is at 13.55 megahertz. and it's telling me that it measures 1.7 ohms. If I can get this cursor up over there. Doesn't want to work. 1.7 ohms. That's as close as dead short that you're going to get. You'll also note, those of you who are familiar with Smith chart, okay, and right here is a perfect 50 ohm match. Now, we're obviously not at 50 ohms, we're 1.7 ohms. So this is dead short, and over here is completely open. Recognize that this is open line. So I know that this transmission line is exactly resonant at 13.55 megahertz, and that is determined because anything up here means the line's too long, anything down here, the line's too low. This dot is right on 0 ohms of reactance. It's not too long, it's not too short. In this case, what I've done is I set that tap point at that 8.25%, and you'll see that this line still shows 13.5. This is the resonant point. This brown line is the impedance, and right now it's reading 99 ohm. One end's still open. It's not hooked to your antenna yet, but I thought you might be interested to see that it still shows its resonant point. The resonant point is here. This is the low SWR, and this is how the impedance peaks right at that point at about 100 ohms. This is kind of meaningless because in the first instance, we're measuring the quarter wavelength length of that line. And when we hook it to the antenna, you'll see how it works as far as a match is concerned. I just thought you might find this to be rather interesting. So here is my antenna. This is the sample. Up here is where the chimney is. Where this rope goes is to the fence. In this instance, I'm showing it with the feed line coiled. This is this ugly mashup I put together, a couple of connectors to terminate these type F RG6 connectors. There's a BNC connector. This goes down to my antenna analyzer. Piece of wire tying all three of these together. And then this little piece of printed circuit board material, I just tie wrapped it so I can tie the thing off and tie the interconductor straight to this radiating element. So that's a quarter wave, or a half wave, excuse me, half wave resonating element. This is the quarter wave matching section, and this little piece of coax goes to where this tap point is, and that's the antenna. This next slide, I'm going to show you what it looks like. This is how I put that little tap together for a later example. I built a 10-meter version just to see how it worked, and it worked equally well. This is a piece of plastic I picked up at Tap Plastic. It's made out of what's called high-density polyethylene, HDPE. I just, all you need is a hacksaw and a drill, and this is a compression clamp. So as you clamp that down, the coax can't pull out. And then I use a piece of braid, so as the wind whips this thing back and forth, nothing breaks. It's real flexible. And when I put it together the second time, I actually went online and I bought some type F T-tap connectors, and then an adapter from type F to SO239. So these are nice weatherproof connectors and do a much better job of using that RG6. I should also mention that you don't have to use RG6 for your matching section. You can use any coaxial cable that you like. You can use RG58 or RG59 or RG213 or RG8 or RG8X. It doesn't matter. They all work exactly the same way as long as they're a quarter wavelength. I just happened to use what I had. And as I said, it does have some advantages. So here's the actual antenna. This first measurement, measurement 1, tells me that it was resonant. Now recognize I used the wrong formula in building that matching section, kind of throws that numbers off, but you notice it's got a nice resonant curve down here. So it's resonant at 13.41 megahertz and the SWR was 1.22 to 1. That's not bad for first try. And that's with the feed line straight, the matching section in a straight run between the chimney and the fence. I was curious what would happen if I coiled the coax, which in the particular instance I was playing with, I wanted to do because it greatly makes things smaller and simpler. When I coiled the line, the SWR dropped to 1.08 to 1. And the resonant frequency changed from 13.41 to 13.36. So there was a slight change. But you can see how sharp that is. And by the way, the 2-to-1 SWR bandwidth was 390 kilohertz, the entire 20-meter band. Perfect match all the way across the 20-meter band with this crummy piece of coax and a half-wave radiator. Pretty impressive, huh? So let's talk about part 2 of this. The first part was, can we end match an antenna and do it with something as simple as a piece of coax without any exotic coils or high voltage capacitors or transformers? And let me talk about that transformer thing a bit. There's a lot of antennas that guys are using, especially these guys that are doing summits on the air, the soda guys and people that like to take their rigs out backpacking and that kind of thing. They buy these antennas called end-fed, which is exactly what you were looking at. But instead of using this transmission line approach I've been using, they use a matching transformer. And some of them use a 9-to-1 transformer, and others use a 49-to-1 transformer. What's tough about an end-fed antenna is the impedance on the end will vary anywhere from 1,500 ohms to 4,000 ohms. So you can see where a 49-to-1 transformer, 49-to-1 times 50 ohms is going to work better for a high impedance end-fed. If it's a low impedance end-fed, the 9-to-1 transformer is going to present a better match. We don't have to mess with any of that. We can get a perfect match and not be limited to 2 options of these Vallon type matching transformers. So this is a model of Mike's antenna using this 100-foot tree, and it's sloped, as you can see here. And I wanted to see what the pattern would look like, the radiating pattern. And when you're putting antennas together, the SWR, the only thing that SWR does is allow your transmitter to feed all of its power to the antenna. These modern day rigs are looking for a 50 ohm load, and the SWR only impacts how the transmitter works with the antenna. It says nothing about how well the antenna radiates a signal. SWR and an antenna's performance are 2 entirely unrelated topics. Most people won't believe that, but it's actually the case. So here's what happens with that antenna that I showed you. It's 100-foot mounting height. If you look at this radiating angle, I think this works out to be 30 degrees. This maximum radiation point is right there, that green dot, about 30 degrees. And I thought, well, that's not too bad. It's a very nice, clean pattern. It certainly isn't a DX pattern, but it's pretty clean. I thought, well, what happens if you were to lower that antenna instead of at 100 feet, we're at 90 feet? Look what happens. According to EZNEC, now all your signal is going straight up. That green dot is the radiation, the primary radiation angle. And I thought, God, how can that be? That doesn't make a darn bit of sense. So what I did is I used another modeling program, one called 4NEC2. And if you look at that, lo and behold, this pattern looks like this pattern, looks like this pattern. There's very little difference in these patterns. The difference is this slight difference in where the peak point is, which really doesn't say anything about the antenna. They're all pretty much this same shaped pattern with some slight differences where the peak is, but it's not very pronounced. Okay. So then I got to thinking, what happens if we were to take this same antenna and make it more of a vertical plane? What happens to the radiation angle? So here it is. I made that tree grow a magic 30 feet overnight. And then I said, let's see what it looks like. Look at that. That is profoundly different. You'll see that this radiation angle, if I get this cursor working again, is down around, I think it's 13 degrees, if I recall right. I can't see it on my screen, but you can see how that pattern changed significantly. So when people say that verticals are low angle radiators, I think you can see why you want to believe that. They're also a little bit noisy. But again, recognize what I mentioned earlier. You can have a horizontal wire that you feed on the end using this method. You can have a zigzag wire that you feed on the end in this manner. You can have a vertical antenna that you feed on the end with this arrangement. They all match in the same manner, and they all perform well. It's the angle of the radiator relative to the Earth that really determines this radiation characteristic, and what your elevation is relative to the Earth that determines this pattern. And that, ladies and gentlemen, is my presentation. Time for questions.
Oh, thanks, Phil. So if anyone wants to ask a question, you can unmute yourself down in the bottom left. If you just press that button down in there, the mute button, and then you can ask a question.
I have KO761.
Then Neil?
Yes, when you look at that pattern, the radiation pattern, how does it relate to the direction of the slope? If the antenna is sloping from the tower, from the tree down towards the north, which direction would that pattern go?
It would be towards the north.
Towards the north, okay.
Any other questions?
I had a question.
Yes.
How was the effectiveness of the 20 meter, the first one you tried, the shorter antenna for that band? And was that horizontal or was that a sloper also?
It was a sloper.
And
it went from about 20 feet, maybe 25 feet down to about 5 feet. But I just hooked it to an analyzer. I never attached my rig to it. I was just kind of curious if I could perform a match. So how well it works, you can plot it and you can get a feel for it. But I didn't try it.
Okay, thanks.
Did that give you an answer?
Yeah, I can use the program.
Oh, absolutely. Yeah, you can plot those things till the cows come home. You know, the one thing about antennas, everything about antennas has something to do with the Earth. And guess what you have no control over? You have no control over how much conductivity the Earth has, how lossy the Earth is, how far below the surface of the ground, the real electrical ground is. You have no control over any of that stuff. And so as ham radio guys, we're constantly fighting the dirt. We're not really fighting the antenna. Earth is either your friend or your enemy. The perfect Earth, of course, is your aircraft carrier in the middle of the ocean. That's the one you want. But you're liable to get bit by coronavirus if you try that. Any other questions?
Phil.
Yes.
Mike has a 100-foot tree and you magically extended his antenna 30 feet. What would you suggest for Mike's 100-foot tree?
Well, if you look at it, the tangent you know, from the peak of the tree down to the ground was 130 feet initially. And so you saw the pattern that resulted. It's this nice, clean pattern. But overnight, I thought I just wanted to see what would happen with the same relative parameters to make it vertical. And to make it vertical and keep everything the same, I had to raise the tree to 30 feet just to see what would happen. But it vertically oriented radiating element has a much lower radiation angle than anything that's horizontal. And that's really all that that says. What really matters is what you have to work with. And that's literally what you're going to end up doing. What do you have to work with? I just thought it was kind of interesting to compare the two.
Could you do a inverted V over the branch?
Yeah, but he wanted something that was end fed. And an inverted V, you have to feed in the middle. I mean, you could.
No, just slope.
You could go up, you could go back down as long, yeah, you can do that. You can do that all day long. As long as it's a half wave radiating element, it'll work like a charm. And by the way, when you do that, you'll find that the high current point is exactly at the apex of the V, because you feed it at the high impedance point, the high voltage point. The peak current's going to be dead square in the middle, and then the remaining end's also a high voltage point. Any other questions?
Yes, I have another question. One of the benefits of using an end-fed half wave is that the antenna will also work on all of the harmonics. You can use it on the second harmonic, third harmonic, etc. And like, as you said, the commercial end-fed half waves that they sell out there usually come with a 9-to-1 transformer. Is there going to be any difference by using your kind of matching system instead of that transformer as far as operating an end-fed half wave on its harmonics?
Yes. And I'm not certain what it's going to be. Recognize that what I've done is I've created a quarter wave matching section. The instant we change that, the frequency that we're using that matching section on, it's no longer a quarter wave. So I imagine matching gets pretty ugly pretty fast. I haven't tried it, or I haven't calculated anything with it, but I don't think it would work as well as the transformer. I'm concerned with the transformer because as you get into higher powers, those are not truly a transmission line transformer. There are most common mode chokes are actually a common mode transmission line transformer, and therefore they're highly efficient. They're 98, 99% efficient. When you start doing special winding arrangements, though, the efficiency of those transformers deteriorates and core losses become a big deal. So while they work really good at low power stuff, you get into 100 watts or 300 watts or 500 watts, I have a strange feeling that you're going to run into some substantial heating losses, but I've not played with it.
Yeah, well, in that case, you just have to use larger cores to dissipate the heat.
Right.
Mm-hmm.
Anything else?
Phil and Neil again. If I understood what you said correctly, we can do an inverted V. So I would assume the feed point would be at the low, going up by the middle up to the high point, and then coming down again to the low point. And the ends would have the high voltage. There should have to be some kind of protection against accidental touching by people or animal on the low end.
Well, any inverted V is that way. The ends of an inverted V are always the high voltage point. It doesn't matter whether you feed it in the middle or feed it on the end. You've got high voltage points at either end. So yes, you need to be cautious of that.
Thank you.
Phil, when you have it set up as
anything else? Set up as a what?
When you have it set up as a sloper, what does the radiation pattern look like if you feed it at the bottom versus feeding it at the top?
You'll have identical radiation patterns.
Okay.
And it's much easier to feed it at the bottom. You know, the nice thing about feeding it on the end is your neighbors don't see the feed line. So they don't necessarily know you have an antenna. That feed line's quite a giveaway.
Right.
Anything else?
Yeah, Phil,
Yes.
on a practical level, how is that end-fed sloper working out for Mike?
Oh, we never put it together.
Okay.
This was an experiment.
Because he doesn't have a 130-foot tree.
It was real world.
I'm not trying to play stump the
imagination.
band or anything. You know?
He told me he was afraid that tree was coming down. So if they
Well,
haven't taken it,
I do, Phil, I just so you know, I do have a 100-foot oak tree in my backyard, but it would have to be, in order for me to feed it, it'd have to be zigged and zagged and everything. So what I'm gathering from what you're saying is that you set up the lengths according to your formulas, but when you actually mount the antenna into a tree, things are going to change depending upon how high it is, what angles your little zigzags are, and so forth. And I just
that's
wanted
true. That's true with every
anything.
antenna.
I understand that.
The only thing that we've done is we've allowed you to feed it on the end, so you don't
Which does
have
make it a lot more convenient.
it makes it more convenient and less obtrusive.
Right.
That's the real advantage of it.
Plus, it sounds to me like you're going to get as good a performance as anything you could order, you know, from a Radio Shack, or not a Radio Shack, but you know what I mean, a radio supply place.
Well,
You know, you aren't sinking a whole lot of money into it either, you know?
you know, the guys that build these wire antennas, you know, the only thing that they've got over you is the fact that they got a machine to make it look pretty. But as far as performance is concerned, a wire is a wire is a wire. And as long as you match it properly, it's going to be fine. And you know, those store-bought antennas have the same issues as one you make. You know, when they come from the factory, they're not cut for the frequency you wish to use it at. They may be a little too long, they may be a little too short. The only way you know is when you actually put it up, make some measurements, and make the appropriate adjustments. So again, they have nothing over you. They just put it in a pretty box and added a nice price tag to it. And you know, all you need is a hunk of wire and some insulators. By the way, 3/4 inch PVC makes great insulators, and it's dirt cheap. Anything else?
I think this is, I think this proved to be quite a good communication tool. The presentation was great, I appreciate it, but I think the media also has proven itself to be very effective.
Yeah, I think the Zoom thing worked real well. Well, that's all I have, gentlemen, unless there's any other questions.
Great for you.
Thanks, Phil.
Okay.
Thanks, Phil. Great presentation.
You're quite welcome.
All right. Well, that was all the content that we had for the meeting tonight. I mean, if you guys want to hang around and chat amongst yourselves, it doesn't cost anything to keep this running. So there's a whole bunch of people on here. So if you want to have a informal chat.
What's the count now, Kevin?
It's 29. So everyone stayed around.
Very nice. I'm very pleased with how this worked.
Yeah.
Neil, if you ever, after we get out of prison, if you ever want to try one for real, I'll offer my my site here to give it a try.
Well, it's easy to do. What band are you thinking about?
80.
Oh, that's the perfect one to do it. That's the hardest one to have an antenna for.
Yeah. We'll talk about it when the time comes. Thank you.
Fair enough, Neil.
Thank you very much. I enjoyed the Zoom event.
Yeah, that worked well, Jerry. I'm kind of tickled with it, actually. I've got another one tomorrow for my SIR group.
Are they using the same thing as well?
Yeah, same.
Okay.
We're Zooming.
Okay.
We'll see how it goes. You know, our SIR group, we typically have about 110 people at our luncheons. And, you know, we have a speaker and that kind of thing. And of course, with what's going on now, it's not possible. So the executive committee is going to meet via Zoom tomorrow, and we're going to talk about this. We might be able to hold our luncheon time frame and actually have speakers make their presentation via Zoom and kind of keep people in the loop. I'm very impressed with how this works.
Bill.
Yes.
Hey, I just want San Diego County Aries meeting, and on Sunday, an LAX Aries meeting via Zoom. And those folks have been doing it a little longer. And so my word to you is keep it up. Don't get discouraged, because this is a marvelous way of training. And, you know, personally, I think this coronavirus thing is going to change the face of the world, the way we do business, the way we educate, and so on. So keep at it.
Okay.
It's great.
I just had something pop up from Marty. The question was, can a 40-meter end fed be used on other bands? Since I've not played with that or done any calculations with that, with a tuner you probably can. But again, the advantage of doing what I'm proposing is that you get a perfect match coming out of the tube. So if you're doing an end fed with an antenna tuner, you know, the pattern's going to be, you don't know, it's just going to be different. And I suspect you can probably make it work. You have to just try it and see.
Phil, do you
Anything
think
else?
that it would be possible to use a single feed line and put 3 or 4 different bands at the end and make the 3 or 4 slopers?
Well, recognize what we're doing. We're building a quarter wave matching section to match impedances at a specific frequency. So the key, you know, you can have a bunch of different resonators. The problem is the matching section is not going to be a quarter wavelength on those other frequencies. Now, if it was an odd multiple of a quarter wavelength, say 3/4 or 5/4, yes, that's going to work perfectly. In fact, the 10-meter version I did, I actually used a 3/4 wavelength matching section because it was a very, very high mounting height and just a short 10-meter radiating number. And those things you can do, but you are compromising yourself when you're trying to do multiple bands. So you'd have to try it. Bye, Art.
When I operate portable in the park, I use a link dipole. And I just made a link for 20, and today I finished the 30. The only way I would see that it could work is if you connected the link for the one end and then changed the stub for the band. In other words, have a 40-meter, let's say start with 20 minus 20, and clip the link and add it to 30, then I would have to also either add or replace the stub to be a 30-meter stub. So it wouldn't be great for a permanent situation in the house, but out in the park, you know, I just connect the links, you know, just lower the ends and connect the links for, you know, a couple hours of operation. So there may be a way possible, but
well, there is. Jerry, in my QTH here, I built an 80-meter J-pole horizontal mounted along my fence line. That's a very unusual antenna. And I use ladder line for the matching section, homemade ladder line. So I have a perfectly resonant 1.03 to 1 80-meter J-pole horizontal, and it works pretty well. Everything goes pretty much straight up, but it covers the local area nicely. But I use it single band. And then for 30, I've got an Eve mounted dipole that nobody can see. For 40, I've got a pair of verticals with gull wing fence mounted again.
Simon.
You know, I've got some very strange antenna arrangements. instruments, and they work. But if you can do an individual antenna per band, it's a lot easier to get a nice match.
Yeah.
How you doing, Gert?
Pretty good.
Pet
Not
a
lacking
cat?
for friends.
You got help there, do you?
I got help.
Cool.
Yeah.
Well, I think this was fun. I enjoyed it. I hope you guys did as well.
Entirely.
Thank you so much for the presentation.
Yeah.
You're very welcome. You guys take care. And by the way, Jerry, I'm glad to hear you're feeling better.
Thank you so much.
Yeah.
Enjoying good health.
Yes. All of you guys stay healthy. Oh.
I want to say hi to Margaret.
Ah.
Margaret, it's Paul.
Hey, Paul. Hi. How you doing?
Good. You still have the same email address?
I do. I have the same email address.
Okay, I'll email you.
Excellent.
Good to see you.
Good to see you.
Yeah, good to see both of you.
Oh, thank you.
Yes. Oh. Wow.
This is going to be placed on our net, I assume, Carol?
From what I understand, the recording is going to be put up on our YouTube channel, so it'll be accessible to anyone who couldn't make it. Also, remember that our net tomorrow is the 8 o'clock net is going to be Kevin is the net control, and for the 10-meter net at 8:30, Tom W6 Bravo Sierra W6BS is our net control. And of course, the Health and Welfare Net will be at 7:30. So we'll be seeing you there.
Okay. Look forward to seeing y'all.
Good night.
Yes, you all have a good night.
You too.
Hi, Carol.
Thanks, Carol.
Hey, how do you get out of this thing anyway? I'm stuck up there in the little box.
It says leave meeting. You click leave meeting in the lower right-hand corner. You get out.
Okay, that's it. Okay, I thought, does my picture come up at all when I start talking, I guess?
Yes, it does. Yes.
Yeah.
Oh, okay, I was wondering how this thing worked. All right. This is the first time I've ever used Zoom. Hey, I might try to make a 10-meter vertical so I can work with verticals for the net. Maybe I can get you both ways then, horizontal or vertical. Okay, I enjoyed it. I really do. Antennas is not one of my best subjects. I like radios. All right, guys, everybody have a good night. We'll talk to you tomorrow night.
Thanks, Jim. Thank you.
This was very useful. I really liked the media as well as the presentation, and it's nice putting faces, matching them up with names and calls. So as a newcomer to the club, I really liked it.
Great, thanks for joining. Yeah, in some ways it makes the meeting kind of easier, like you say, because you can see everyone's call sign, you can see their name, and it's a good way of seeing the presentation materials as well.
Mm-hmm.
Yeah, it worked well, it's good.
And the other good thing is if you have trouble hearing, you can just turn up the volume and listen.
Right.
not bad at all.
Crank it up.
Yep.
That's very good.
So
and
that's a plus.
We get the benefit of having the recording too. So we can record the whole thing and then share it for everyone else.
Yep. So we get to share it, including, it was cool about the guy being in Texas and joining being for the club too. Not something he'd have been doing conventionally.
That's
so
true.
There's a lot of pluses to the virtual. Of course, we didn't do a whole lot of snacking, but that's okay too. We've probably been doing enough of that anyway. So anyway.
One suggestion, if this thing being at home lasts too long, we could possibly consider having a show and tell on a shack in here. 2 or 3 different people making showing their shacks and what else they do.
That's a good idea. Yeah, that would be good. Like when we have the homebrew days and stuff. day and that sort of thing. Yeah, that would be
Great
good.
idea. I like it a lot. Great idea.
Yeah.
You know, even when things get back to normal and we have a regular meeting at the regular site, we could still have a laptop set up in the meeting as well. And then other people who can't actually physically get to the meeting site, they could still join and watch the meeting too. So we keep on doing this.
There's some real pluses to making the best of the technology.
Right. Yeah.
Yeah. One more branch of
Don't some of the other clubs, don't they stream on YouTube? Does the Samuel Morse Club, do they do a live stream of their meeting?
Yes, Samuel F. Morse does that. All of their meetings are posted on YouTube. And there are a number of other clubs going to Zoom. I believe the Elk Grove Flooring Club is going to be doing their meeting on Zoom. And I think I saw a few other clubs that are going this way as well.
Wow. So we keep an eye out for invites for the other clubs. We can get involved in quite a few meetings during the week.
Sure.
Yeah.
You don't like me.
Take care, all. Good night.
All right. Thank you, Cal. Thank you.
I like your background, Kev. Ready to take off, eh?
I'm on the Millennium Falcon now.
Where's your Wookiee?
Let me go find him. I think he's in the back somewhere.
Yeah.
Here he is. Here he is. I found him.
There he is.
He's sitting over there.
I see him. Way cool. Anyway, I'm going to sign off too.
All
nice
right,
seeing everybody. Take care.
Good
night, Gert.
All right, everyone. Well, let's wrap it up. And for next month, I guess we'll play it by ear and see what happens. But maybe we'll do the same thing again next month.
Okay. Sounds good.
All right. Thanks, everyone. Thanks for joining.
Good night.
Thanks. Good night.
73.